Hello everyone. In this video, we are going to take a look at a case when a double integral can actually be represented as a product of single integrals. So these are just regular integrals. Of course, that's a big advantage because you do not have to double integrate. But when can that happen? That's important. Okay, so number one, the limits of integration have to be numbers. So if there are variables, and variables are not only usually allowed in the inside integral, the inside integral can never have any variables in them. If they do, then the integrals cannot be split. Also, the integrand, so we are talking about what we are integrating here. So this function right here, can that be represented as a product of two functions, one only of x and one only of y? So it has to be something like f of x times g of y. Sometimes there is no variable at all. So there may be just x but not y, or maybe just y but not x. That is also would be a splittable case because then the other function could just be chosen as one. However, when you look at this specific example, you may wonder, well, it doesn't look like the e function can be written as a product, but you would be wrong because yes, you can. So there is a rule, and that's property of exponents, that says that whenever you have something to the power, let's say b plus c. So when we see something like this can actually be the same thing as a to the power b multiplied by a to the power c. So this is property of exponents. In the simplest case, when it's just integers, you can think of it as I am multiplying a by itself, b plus c times. Well, that's the same thing as multiplying a b times and then an extra c times. That's where this rule comes in. And so this is what we're going to be doing. We're going to be splitting this thing into two. So this would be like negative 2x plus negative 5y. And whenever there is a plus, a lot of students actually make a mistake and they would have something like this. That is incorrect. You are not adding. Right here, this is not addition, okay? So this is multiplication. So that is why this integral can be split. And once you see that it can, then we can represent this double integral as a product of two single integrals. So one will be just the x integral, which is just going to have e to the negative 2x in it. And then the other one is going to be e to the negative 5y, and then they will be multiplied. Now, another important thing where you can get a little bit mixed up is that which limit belong to which variable, right? Because you got log of 3, log of 4, and then you have 0, 2. What's what here? Well, remember that the inside integral is computed first. And inside integral is the y integral. And so these limits are the y limits. This is the y, how the y changes. And then the outside would be, this would be the x. So that's the x. And so the x limits will become log of 3, log of 4. So don't mix that up. These are outside, okay? And then the inside limits are the y limits. So this would be 0 to 2. Okay, so once you figured it out and once you split it, then you should be able to just integrate it. Very simple, because you should know that integral of e to the number x is 1 over the number, and then the same e happens there, right? And this really comes in from very simple substitution rule. If you just do u equals ax, you would immediately see why that's the case. So this will become negative 1/2, because the a here is negative 2, so it's going to be 1 over that, or reciprocal of negative 2, which is negative 1/2, and then this will be e to the negative 2x. Now we're substituting log of 3, log of 4, okay? So whatever we get there, we're going to multiply by e to the negative 5y would be negative 1/5, e to the negative 5y, and now we're substituting 0, 2. Okay, so let's see if we can just get this done. So if we substitute log of 4 into the first expression, we're going to get negative 1/2 e to the power negative 2 log of 4. And in a second, we're actually going to simplify that. Then we are substituting the lower limit for x, but because we are subtracting, right, this will become a plus. So subtracting a negative becomes a plus, and then we get e to the negative 2 log of 3. Okay, so we got that, and then we're multiplying that by the other one. So this will be negative 1/5 e to the negative 5 times 2. Well, that's 10. And then we subtract, which really is because subtract the negative is a positive, so that would be like adding 1/5, and then e to the power 0, well, that's 1. So you should remember that that's not 0, okay? So we're almost done, and some teachers may say, okay, well, this is fine, but I actually would like you to know how to simplify it. So this part, you really cannot simplify any further, except to say that e to the power 0 is 1. But this other stuff, that's actually really important to know how to simplify that. So let me show you. Because you can also use a calculator. You can just put this thing into the calculator. The calculator will tell you what it is. If you can convert it to a fraction, you will see what it is. But why? So I do not want to use a calculator. I want to just figure this out without. Okay, so here's how you do that. So what we do is we think of this as a product of negative 2 and log of 4. And then we use another property of exponents that says that whenever we have some kind of number raised to the power b and then further raised to another power c, then we just multiply these powers. And we're going to do exact same thing here. So we're going to say, okay, why don't we first raise e to the power log of 4, and then we further raise it to the power negative 2. And so what will happen, these powers are just multiplied, and then we'll get this. So I'm kind of using this rule backwards, right? From the product, I get the left-hand side. But what do I see right here? This is the e, and this is ln. E and ln are inverse functions. That means that they will undo each other's action. If you apply log, natural log, and then you apply e, they cancel each other out, and what you got left is just 4. So this is really just going to be 4 to the power negative 2. Now, what is that? That also requires you to know that negative powers are responsible for not just taking this negative and moving it to the front. This is not going to be a negative answer. Not really. The definition of negative exponent is that you're just going to put it on the bottom. And so it becomes positive, but it's going to jump to the bottom. And if it was on the bottom, the negative, then it would go to the top. So 4 squared is 16. So this would be 1 over 16. So actually, this part can simplify to negative 1/2 multiplied by 1 over 16. Now, very similarly, the other one, if you raise e to the power natural log of 3, that's just going to be 3. And then raise that to the power negative 2, that's going to be 1 over 3 to the power positive 2, which is 9. Okay, so that's it. That's the answer. So if you that's as much as I can simplify it. So this will look like negative 1 over 32 plus 1 over 18. Yeah, maybe you can compute that on a calculator, and then you just multiplying that by the other one, right? Like whatever this other part is. So this is just going to be that plus 1/5. And that would be the final answer here.